Mathematical modeling using quadratic functions. In this video, we're going to look at applications for using quadratic functions. Quadratic functions can be used to model various types of applications. In this lesson, let's take a look at some of these. Here's a sample problem. The equation f of x equals negative 0.45 times x minus 10 squared plus 45. This equation models the quadratic function shown in this diagram. Now we want to analyze this diagram and the equation. What do we know about this diagram? First of all, the direction of the opening. Since the coefficient is negative, the graph opens upward, and so it will have a maximum point. The vertex. The value of the vertex represents the coordinate of this maximum point. The coordinates are 10, 45, which we get from taking these values from the equation. Now, the maximum height is given by the y value of the coordinate. So the maximum height is 45. The x value occurs when y is 45, so the x value is given by the coordinate 10. This could mean that a height of 45 was achieved at 10 seconds if the y represented height and x represented time. When did the object being modeled by this equation reach the ground? Since the object crosses the x-axis, which represents the ground, this happens at 20. Here's another problem. Given the equation f of x equal negative 0.2 times x minus 20 squared plus 85, what is the value of the vertex? Remember, the vertex comes from the h value, the 20, and the k value, 85. So we know the coordinate is 20, 85. And we can verify that by looking on the graph. What is the maximum height? Again, we get this from the equation, or by looking at the graph, it occurred at 85. The x value when this occurred is given by the x coordinate, 20. This could mean that a height of 85 was achieved at 20 seconds if the y represented height and x represented time. When did this occur? The maximum height of 85 is achieved at 20. How high is the person letting go of the object? Since the graph didn't start at 0, but started at 5, we know the person was standing 5 units from the ground. When did this object hit the ground? Well, again, by looking at the graph, when it crosses the x-axis, we see the point is 40.5. This is the value of the x-axis when the graph crosses the x-axis. Now it's time to complete your project and quiz.